Hello, welcome back. Today we're gonna be talking about quadratic inequalities. Uh, for example, let's have x squared plus 5x is greater than -4. So, we want to make sure that it is in the proper form, which is ax squared plus bx plus c is greater than, less than, greater than or equal to, less than or equal to 0. So, we just need to transpose -4 to the other side, which gives us x squared plus 5x plus 4, just flip the sign, greater than 0. So here is our it's in proper form. Now we want to use AC factoring, so we will just equate by 0. So assume that this is 0, it's equals to 0. Okay. Now we can get the values of A, B, and C. So we get 1, 5, and 4. These are the values of A, B, and C. We multiply A and C, AC method. So A times C, 1 times 4, it's 4. And now we gotta list down factors of 4 that add up to 5. So 1 and 4, 2 and 2, 1 plus 4 adds up to 5. So we can take 1 and 4 and split 5 into 1 and 4. We can split the middle term into two terms. So x squared plus 1x plus 4x plus 4 is equals to 0. So now that we have 4 groups, we can make, we have 4 terms. We can make 2 groups with 2 terms each and use common monomial factoring. So here is basically what common monomial factoring is. We have x squared. X squared, when you expand it, is x times x. And we have 1x, so 1 times x. What can we take? What is the common thing that they have that we can take out? We can remove x. So we take out x, which leaves us with x plus 1 plus 4x plus 4. What do they have in common? So 4x, 4, and 1. What do they have in common? They have 4 in common. So we're left with x plus 1. So we can take out 4. X plus 1 is equals to 0. So now that we have a common binomial, we can take that out too. So it's going to be x plus 1 times x plus 4 is equals to 0. That doesn't look like 1. Oh. So now we just equate by 0. So x plus 1, so it's going to be x is equals to -1, because -1 plus 1 is 0. X plus 4, so -4, -4 plus 4 is 0. So these are our critical numbers or our roots. So let's make test intervals. First look at our sign. It's greater than. If it's greater than or less than, we have to use the parenthesis. So negative infinity, -4. Keep in mind r sub 1 should be less than r sub 2. So r sub 1 should be the smallest one. Since -4 is smaller than -1, that's our r sub 1. Anyways, moving on. Since it's greater than, we have to use parentheses. So we have -4 r sub 1, and then r sub 2 is -1. R sub 2, -1, so up to infinity. Now, since our sign is greater than, we could simply just say that this and this are correct. Because if it's greater than, it's automatically going to be uh R sub 1 union R sub 2. Yeah. It's going to be the first and the third if it's greater than. I will show with test numbers to prove. So let's take some test numbers. So negative infinity to negative 4, we get, let's get negative 6. And then negative 4, negative 2, get negative 2. And negative 1, infinity, let's say 7. So let's get our original inequality. X squared plus 5x plus 4 is greater than 0. If we put negative 6 into here, we get negative 6 squared, 36. Plus 5x, it's going to be 5 times negative 6, so it's going to be minus 30. Plus 4 is greater than 0. 36 minus 30 is equals to 4. Oh, is what? 36 minus 30, 6. Plus 4, it's 10. Uh, is 10 greater than 0? Yep. Um, negative 2. Negative 2 squared, it's 4 plus minus 5 times negative 2 minus 10 plus 4 is greater than 0. 4 minus 10 plus 4. 4 minus 10, 6. Negative 6. Plus 4, negative 2. Is negative 2, if is negative 2 greater than 0? No. 7. 7 squared, 49. Plus 5 times 7, 35. Plus 4, greater than 0. That's common sense. Of course, it's greater than 0. So we can conclude that the solution set is let's remove this and replace it with our values. The solution set here is negative 4 up union negative 1 infinity. And we see that the logic applies. We see that where's the equation? Great, when it's greater than, it's not the second interval.